Imagine a town's population has been decreasing at a constant rate. In 2010, the population was 5,900, and by 2012, the population had dropped to 4,700. And assume this trend continues. Predict the population in 2016. So imagine you're at year 2010, and then 2 years into the future, it will be 2012. To go back to those years. So consider now that the population in 2010 was going to be 5,900. And consider now the population in 2012 is 4,700. My question here is going to be to you, how much is the population decreasing per year? Right? How much is it decreasing per year? What would you do? Well, I gather you would probably do something like this. You would probably do, I'm just going to find the difference between the two population values. And then what I'm going to do is divide that by then the number of years. Or in other words, I'm going to divide it then by the changing value, right, of the years. Right? So it was 2010 minus then the 2000. Well, you probably would have done it the other way, though. This way minus then the 2010, right? Let's just say. So what you would have realized is that when you do this calculation, you would have said 5,900 minus 4,700, then divided by 2. So that's going to be 600. Okay, so you're going to say, okay, great. The population is decreasing 600 people a year. So if it's going 600, then that means 2011 it was 600 less, 2012 600 less, 13 6 less, 14 15, and then 2016 it was 600 less than 2015, right? Et cetera, et cetera, et cetera. So that's great, right? In terms of now math, and you could have done it that way, that's not a problem. In terms of math, we can realize that this is basically, we can call this at the top y, the population is a y, and the time is an x. Okay? So basically what you did was you found the change in y, and you divided it then by the change in x. And when we do that, right, mathematically speaking, we should take the y2 and minus the y1 value, okay, and then divide it by the x2 minus the x1 value. And you can, it depends on what you want to call what. It really does not matter now. I'm going to call this the my 2's. Okay, this is x2 and my y2. So let's call this y2, and that's going to be my x2. And then on the other side, this will be my y1, and then that will be my x1. Okay, so now all we have to do is kind of plug it in. And if you're noticing, this looks eerily similar to slope. So 4,700 minus now 5,900 divided then by 2012 minus now 2010. That's 2,100. And that would be equal to now negative 600, right? So I think when you think through the problem, you don't really calculate the negative, which is totally fine, but you know it's decreasing. This just now tells us the sign, and the sign is telling us that it's decreasing. So instead of saying it's decreasing, right, I can just look at the number, negative 600, and know it's decreasing. All right? So this is essentially the slope, or aka the m value, right? So what I now need to do, basically, is I can now use my formula again. I can use slope again. I don't even need a linear equation per se, because we can make certain assumptions that the population is starting with. I mean, there's so many ways to do these problems. We can create a linear equation if you wanted. We could now say that y is equal to negative 600 x, right? And then I would have said, well, what value of the population am I starting at? I'm starting at 5,900, so I could have said plus 5,900. Right, this could have been a linear equation now I could have used. Or you can just literally calculate this problem again by using the slope formula. You don't even have to create a linear equation to do this. Watch. So let me get rid of this for now. I'm going to shrink this work on down. How you guys doing? Hopefully you're having a good year, good semester. All right. Hopefully this video is helping you. Watch. I'm going to use my slope formula again, okay? Now remember, what I'm going to do here is I'm going to say now slope. I'm just going to articulate this, that the slope is equal to the change in y over the change in x. Okay? So what is the slope value? Well, it's 600. They said assume this trend continues, so the decrease is going to be the same. So this is now going to be negative 600 is equal to then change in y. So change in y is always y2 minus y1 over x2 minus x1. So what are your 2 points now? Assume you're starting with this. Okay, you could have started at 2012, by the way. It doesn't matter. But assume you're going to start with these values. And now what we're going to do is we're going to end with a y2 value of, hey, wait a minute, I don't know. That's what I'm trying to predict. I'm trying to predict the population. But the year should be 2016. So all you now have to do is plug these values on in to this equation. So plug in your y2 value of, I don't know what it is, so just plug in y2. Minus then plug in your y1, 5,900. Plug in then your x2 value, which was 2016, and your x1 value, which is 2010. Okay? Literally, you have now one equation with one unknown. All you got to do is solve it. Okay? So it's simply going to be now negative 600 is equal to y2 minus 5,900 all over then 6. You're going to cross multiply here, right? So that's now going to be negative 3,600 is equal to y2 minus 5,900. You're going to add 5,900 to both sides, and that's going to be now your answer. Okay? So that works out to now be y2 is going to be equal to, so we're going to take basically 5,900, subtract out 3,600, and what do we get? 2,300 now. So the population there is going to be 2,300 people. Okay? Or whatever. A town? I guess it's a town of people. Who knows? Maybe it'll be a town of aliens. We don't know. Or ants. Right. So, and not the small, like the small creature ants. I'm talking about like everybody's ant. Like just a group of ants. Like Aunt Mary, Aunt Terry, you know, all the ants, right? So, what we now need to do is, well, we can move on to the next problem, but why move on when we can discuss the same problem even more in depth, right? So watch. The other way I could have done it now is I could have used the blue one. I could have used my blue equation I created, and watch what I could have done. Remember why I'm talking about the population. X will represent now a certain period of time. Okay, so essentially what this will look like now is, remember, X represents a time period. So how much time passed between 2016 and 2010? 6 years, right? So I can have done this. Y is equal to negative 600 multiplied by 6 plus 5,900. Y is equal to, what does this work out to be? Negative 3,600 plus then 5,900. And wait a minute, isn't this the same exact thing we just did? 2,300. Yes, it is. So it does not matter which way you do it. You might say, man, couldn't you just show us that way first? Well, I could have, but I like to take the scenic route. So, also, some people might have trouble kind of creating this equation, but they might say, oh, I can see it through the slope formula. So it really does not matter which way you do it. But now what I'm going to do is now I'm going to move on to the next one. So it says identify the year in which the population will reach 0. Okay? So what I'm going to do, though, for here, and by the way, you can definitely use your slope formula on this. You can do this either way. Slope is equal to change in y over change in x, right? It would have been negative 600 now. Negative 600 is equal to your y2 value. Well, this now population is equaling 0. So the final point y2 is 0 minus your initial of 5,900. All right, my x2 is the question mark. I'm trying to find that final time. Minus then the initial, I'm just choosing to use the 2010 value, so that has to be now the number in there, 2010. And it says identify the year. Okay, so when you do this now, it will, whatever you solve that for, x2 will be the value. All right, and that will be the year. What we could have done also is we could have used our now linear model. So just solve this out and you get your answer, okay? Or what we could have done was we could have used y is equal to negative 600x plus 5,900. Realize that y represents the population, so 0. X represents the time frame, not the year, but the time frame over which the population is changing. So 600 times x plus 5,900. 50. Come on, you can do it, Andrew. Good. Now add this term on over to the left-hand side, so it's 600x is equal to 5,900. Divide both sides by the 600. And what do we get? So 5,900 over 600. So it looks like 9.83 years, right? 9. So 9.83 years away. Now it says identify the year, okay, in which the population will reach 0. So if you think you're starting in 2010 and think about this, you're going to accumulate 9.83 years. You didn't get to 10. 10 years would have been 2020. But you got 9.83 years. So it's identifying the year in which, not the exact time in that year, but the overall year. So the answer would be then 2019. All right. What you would have realized here when you solve this, it would have been negative 600 is equal to negative 5,900 all over x minus 2010. Watch what I'm going to do here. I'm going to do a little magic, a little switcheroo between the numerator and denominator there. It's almost like a cross multiplication. Now what I'm going to do is I'm going to add then the 2010 to both sides. 2010. I keep wanting to write 2100. I guess I'm just looking forward to the future. So now you're going to divide this first and then add it to that number. Okay? So negative 5,900 divided by negative 600. Add that then to 2010. And what do we get? We get a year of 2019, 2019.83. Oh, interesting. It kind of just worked out to be the exact same thing. But this is now, like I was mentioning, this is going to tell us the exact point in the year. But again, we're not going to round up, right? Because the logic of the question is not telling us to round up. It's saying in what year does the population reach 0? It doesn't reach 0 in 2020. The population is already going to be 0 by 2020. So again, the year in which it reaches, you'd have to round this number down to get your answer. All right. So, oh my goodness, how long was that? 29 minutes. So guys, thank you very much for tuning in. I really do hope this helped. If it did, help us out. Tell your friends, like, subscribe. We'll see you soon. Take care.